this, right? Gases, right? Gases has to be designated by what? Temperature, pressure, and volume, right? These are three parameters
Yeah.
it has to designate, right? We know the conversion, right? That Kelvin to centigrade, right? 273, we know it. Now, the
Yeah.
units of pressure is what? The unit of pressure will be, it can be pascals, right? And can be
Yeah.
bar. What is the relation between pascal and bar? 10 to the power 5 pascal equal to 1 bar, right? Clear? Is it clear
Correct.
over here? Now, we have
Correct.
to now go to the, this will be coming in exam. Already sent you that picture to you, huh? This one, right? 100% will be coming, right? Just to know that this will be coming in the multiple choice, right? Multiple choice question, right? Hmm. Now, if you see when we talk about when you talk about the when you talk about the pressure, we know that if we increase the pressure, what happens if we increase the pressure? Tell me the volume. Tell me the volume decreases. Can you see this? When you increase the
Yeah.
pressure, what happens? The volume decreases. Agreed, right?
Yeah.
If you see that when we take the when you increase the pressure, the volume will be decreasing, right? Isn't it clear? So this is very
Yeah.
important that if you see that pressure is inversely proportional to the volume, so it will be P is directly directly proportional to 1 by V. We can write. Now if you remove the if you remove the proportionality sign, right, Ola, you'll be getting what? You'll be you have to replace with a constant, right? P is equal to constant into 1 by V. Then we rearrange and find out PV equal to a constant, right?
Yeah.
Clear? It's clear. Now if you see that when you take the pressure and the volume, right, it will be graph like this, right? It will be graph like this, right? Now if we take pressure by 1 by volume, it will be a straight line, right? Clear? Got it? Now, secondly,
Yeah.
now see if you see that when we multiply the pressure into volume, it will be pressure, it will be getting a straight line over here, right? Agreed? Hmm? Get my
Yeah.
point? Now, next thing is that if you see when we talk about the suppose we increase the temperature, do these graphs, right? This will be coming in a board exam. This graph will be 100% coming, right? Now, see if we take volume versus temperature, we know what, that if we are increasing the temperature, what happens? The volume increases, right? Clear? Fine.
Yeah.
Now, can we do one thing? If we decrease the temperature, what happens? The volume decreases, right? Isn't it simple? If we increase the temperature, the
Yeah.
volume increases. If we decrease the temperature, volume will be decreasing. So can we find out a temperature where the volume becomes zero, right? Isn't it? Can we find the temperature? Yes. So that's called absolute zero, right? So absolute zero is what? Absolute zero is the temperature which you get, right? Now we get what? Temperature is directly proportional to the volume, right? So
Yeah.
we can write like this: V by T is equal to a constant, right? Isn't it? Now second comes what? This is called a Charles law. Second comes the Gay-Lussac's law. In the Gay-Lussac law, we are seeing what? Pressure is directly proportional to the temperature, right? If you increase the temperature, what happens? The pressure increases, right? Clear? Understood? So
Yeah.
P by T is equal to a constant, right? Clear? Understood this part, right? You get my point, right? You get
Yeah.
get my point. So now going to the next part, right? If you see when we talk about combining all this reaction, right? Combining all these equations, what do we get? Tell me. We get what? We will be getting P by PV by T is equal to a
Yeah.
constant, right? So for any gas, if you take multiply pressure by volume and the divide the temperature, it will always be a constant, right? So can we write down this equation? P1 V1 by T1 is equal to P2 V2 by T2. Is it clear? Understood? Can we write this? Yes, we can write. Understood?
Yeah.
We can write this, right? We can write P1 V1 by T1 equal to P2 V2 by T2. Agreed? It's clear to you,
Yeah.
right? Got it? So
Yeah.
P1 V1 by T1 equal to P2 V2 by T2, right? Clear? Any questions? Please tell me.
It's
Over
clear.
here is clear? So that's a very important information we come across, right? That P1 V1 by T1 equal to P2 V2 by T2, right?
Yeah.
Fine. Now, the next part is that if you see when we talk about when we talk about this, right? If we have to see that, don't know what the vocabulary of the question will be coming. The vocabulary of the question will be, suppose we are changing the pressure, right? So first, suppose we are changing the pressure. What will be the suppose you're changing the pressure from P1 to P2. Now suppose I'm changing the volume from V1 to V2. Understood? Clear? Understood? Clear?
Yeah.
Now, suppose I'm changing a temperature T1 to T2, right? Clear? Understood? Right?
Yeah.
Understood. So there'll be changing language, right? That we are changing the pressure to a new pressure, volume we are changing to new volume. What will be the temperature be, right? One will be not given. Got it? What should be the language? The language is something like this. See, what happens to a fixed volume? Volume of a fixed mass of a gas when its pressure and absolute temperature are both double, right? Clear? Understood? See,
Yeah.
we are changing what? We are changing the pressure. We are doubling it. Temperature also we are doubling it. What will happen to the volume? See, got it? Do you understand this? What should be the language, right? You get my point? That pressure is changing. We are changing the pressure. We are changing the temperature. What should the volume be, right? Clear?
Yeah.
Suppose a question like this. Suppose if you do this question, and always remember that in P1 V1 by T1 equal to P2 V2 by T2, right, Ola? There's no restriction. There won't be any restriction on keeping the units, any fixed units, right? Means if you take pressure in Pascal, you have to take P2 in Pascals also, right? You don't have any commitment to take the units, right? If you take the volume in suppose centimeter cube, you have to take the V2 in centimeter cube also, right? Clear? Get my point?
Yeah.
Get my point? If you're taking the temperature, if you're taking the temperature in 0 degrees centigrade, you have to take this in centigrade. But I advise you, always temperature now you convert to Kelvin, right? That will be safer, right? Clear? Clear?
Yeah.
Let me show you a question over here if it's there. Just 1 minute. Just 1 minute. See, a 2.5 decimeter cube container of helium at a pressure of 85 kilopascal was heated from 225 to 75 degrees centigrade. The volume of the container expanded to 2.7 decimeter cube. What's the final pressure of helium, right? This suppose is a question, right? Get my point. So
Yeah.
this is a question you're having. Now, can you do this question? Can you solve this question, right?
Okay.
In this question, we have to just maintain that the volume unit should be maintained, right? Got it? Right?
Yeah.
The kilopascal temperature, that's all, right? Clear? Fine?
Yeah.
Any
Yeah.
question, please tell me, right? See, leave it. All leave it. Let's go to the part, right? Now, see, if we are going to the part of the ideal gas equation, right? Hmm. Now, you have to understand that when we speak about ideal gases, right, there are two assumptions we take. You can write down. When you're taking ideal gases, we're taking two assumptions, right? What's the two assumptions we are taking? The two assumptions we are taking is that if you see that when we talk about the ideal gases, first thing is that it is assumed that there is no intermolecular wait, let me frame it in this way. The first thing is that there is no interparticular force of attraction between the gas particles, right? Clear? If you see a gas, right, with the first assumption is that there's no interparticular force of attraction, right? Clear to you, right?
Yeah.
To get my point, there's no interparticular force of attraction between the particles of the gases, right? Clear? Is it clear to you? There's no interparticular
Yeah.
force of the gas. There's no interparticular force of attraction, right? Clear? First thing. Second thing is that the volume of the gas particles, right? This is million times bigger, which I have to draw, right? Billion to the power of trillion times bigger, which I've drawn. So the volume of the particles of the gas, total volume of the particle gas, is almost negligible equal to zero, right? Clear? Is it clear? They don't contribute
Yeah.
to the volume. These are two assumptions we have taken for the ideal gases, right? And quickly, can you write down this important trick? A real gas, a real gas will be behaving like an ideal gas. Please write down this. At very low pressures, please write down very low pressures,
Yeah.
right? And at very high temperatures. Write down this, right? Is it clear? Ideal gases are what? Ideal gases are those which has got no interparticular force of attraction, right? Fine, fine, isn't it? The volume of the particles occupied the
Yeah.
gas is almost negligible, is equal to zero. And when does the real gases behave as the ideal gas? Tell me.
Low
At
temperature, high.
very low
Yeah. Low
pressure,
pressure, high temperature.
very low pressure, not low pressure, very low pressure, and very high, not high, very high temperature, right? Clear? This
Yeah.
is all you need about the real gases ideal gas. That's all, right? Understood? Now we are taking what? We are taking PV equal to nRT, right? This equation we are taking. Fine. We are taking PV equal to nRT, right? Hola, right?
Yep.
PV equal to nRT. Now you have to know an important thing that in PV equal to nRT, pressure must be in pascals, right? Write down this, right? Must be in pascals. not kilopascal, right? Clear? Note down this.
Okay.
Volume, maximum students, they take decimeter cube. No, volume must be in meter cube, right? Clear?
Okay.
Got it? And temperature must be in Kelvin, right? Clear? Hola? Get my point?
Okay.
Get my
What would
point?
meters be in like?
Yeah,
What
yeah.
would meters cube be in like
This
liters?
this one, meter cube, decimeter cube, and centimeter cube. See, in
Yeah,
IBDP, we
but
don't use
what
liters.
would it be?
I'm telling you,
Yeah.
one decimeter cube will be equal to 1 liter. But in IBDP, we don't use liters. I'm telling you, in APU we use. We don't use
Okay.
in IBDP. We use decimeter cube, not liter, right? Not milliliter, right? Milliliter is centimeter cube, right?
Yep.
I don't know. I don't know. I'm not so I'm not so I'm not aware of liters that but I know that 1 decimeter cube is 1 liter, right? Fine.
Yeah.
Good question. That what will be, right? Interesting question, right? Centimeter cube is milliliter, right? You put the m in front for centimeter cube. Anyways, so we don't use liters, right? I'm telling you in IBDP, right? Do you get my point? Meter cube, decimeter cube, centimeter cube. If you want to convert decimeter cube into meter cube, you do what? Tell me. Divide by 10 to the power 3, right? If you're converting centimeter
Yeah.
to decimeter cube, you do what? Divide by 10 to the power 3. Is it clear? Understood?
Yeah.
Do you get my point? Hmm? So these are the things you have to master, right? Clear? Okay.
Yeah. Yeah.
Any questions? Please tell me over here. No? Fine. Now,
Yeah, it's fine.
now, see this. Now, see, whenever we are getting a question like this, see, question like this. Suppose they're saying what a helium party balloon has a volume of 18 decimeter cube. At 25 degrees centigrade, the internal pressure is 100 kilopascal. Calculate the mass of helium, right? Isn't it? Fine. So in this question, you do what? Pressure is what? Pressure is 108 kilopascal, right? Clear? Understood? Fine. We convert
Yeah.
it to what? We convert it to Pascal. See? Got it? We first write all the information we are given, right? Clear, Ola?
Yeah.
First write all the information which is given, right? Pressure is 100 kilopascal. Volume is 18 decimeter cube, right? That is what? Decimeter cube to convert to what? Tell me. Centimeter in meter cube, right? See? 10 to the power minus 3.
Yeah.
Temperature must be in what? I told you? In Kelvin.
Kelvin.
Kelvin. Here in PV equal to bound to follow the units. In PV equal to P1 V1 by T1 equal to P2 by P2 V2 by T2, you're not bound, right? Clear? You're not bound to it, right?
Yeah.
Clear to you? Understood this
Yeah.
part? So that's a very important portion you have to master, right? Isn't it? So this is clear to you. Do you get my point? Hmm?
Yeah.
Now over here, see. Now if you see when we talk about this, that the equation is what? PV equal to nRT, right? So see, we have got P over here. We got V. We got T. We know R. We have to find the number of moles first, right? Right? We get the number
Yeah.
of moles. Agreed. Did you get my point? What the question is
Yeah.
asking, what the mass of helium, right? Once we find the number of moles is equal to what? Tell me. Number of moles is equal to, tell me. Mass by molar mass, right? Isn't it? Molecular weight. Mass by molecular weight. Is it clear?
Yeah.
Get my point?
Yeah.
So
Yeah.
that's the thing we have to master, right? Clear? This is one type of
Yeah.
question, right? See, PV equal to nRT, we filled all the data Pascal, volume we filled up in meter cube. Remember the meter cube, not decimeter cube. Temperature in
Yeah.
Kelvin, the universal gas constant, right? Get my point. And we're getting we can find out R over here. We can find out N over here. Once we find out N, we multiply it by the MR of helium, that is 4. We get the mass in grams, right? Clear? Any question?
Yeah.
Please tell me. Now see now now, if you have got a density, right? This thing you have to know that trick. If you have got density, right? Always remember that density is what? Density is equal to what? Tell me, density equal to mass by volume, right? See, in the density, two informations is given. Can you see this? Two information, right? Mass is given, right? Understood. Understood. And
Yeah.
volume is given, right? Isn't it? Volume is given, right? Decimeter cube. Understood. Clear? You get my point? Understood?
Yeah.
Mass is given and decimeter cube is given, right? Clear? Do you get my point? Huh?
Yeah. What's the unit you used on the density? Grams, right?
Uh, density I've used. Uh, Density is mass by volume.
Yeah.
Understood. So in this
So
density,
it's so,
in this density per information, we have got
yeah,
two
grams.
information. See,
Yeah,
mass is
grams
given,
per centimeter cube.
so mass is given, and volume is given. See, volume is how much? 1 decimeter cube. Got it?
Yeah.
Do you get my point? See, two information is given. So mass is given 1.65 grams. Volume is given 1 decimeter cube. Understood.
Yeah.
Temperature is given 27 degrees centigrade. Understood. Understood.
Yeah.
And pressure is given how much? 90 kilopascal. What do you have to do? Tell me. Kilopascal is given. What do you do? Convert this to
To
Pascal.
convert it to pascals, yeah.
That's all. Temperature you have to convert to. Tell me. Kelvin. Understood.
Kelvin.
Get my point, right? Clear to you, right? Fine.
Yeah.
Temperature we have to tell in Kelvin, right? So we have to add to something, right?
Yeah.
Clear? But that's all. They're asking the what is the molar mass of the gas. So what we do? PV equal to nRT. We put pressure. We put volume. We put temperature. We have got R. We find the number of moles, right? Number of moles
Yeah.
equal to mass by mR. So number of moles you find out from here, Ola. Understood. Then mass is given. Understood. Mass is given. See how much? 1.6 grams, right? Fine. We rearrange. Mr is equal to mass by number of moles, right? Mass is given 1.65. You get the number of moles from this equation. You put understood, Ola. Understood. We get the Mr of that
Yeah.
gas. Any questions? Please tell me. Any questions? Tell me. Okay. Hmm?
Yeah.
Got it?
Yeah.
Please tell me. Fine.
Yeah.
Okay. See,
That's right.
do you know what? This thing I'm going to tell you. This thing. Huh? Hmm. You know, I'm telling this thing to you. Wait. Okay. So this is done. This is done. Anything else? See, this thing is read, huh? What did you do? A real gas behaves with the ideal gas at very low pressures. It behaves with the ideal gas at high temperatures, right? Clear? This thing you have to remember.
Yeah.
And what's the assumption you made for the ideal gas? The volume of the particles is negligible. There's no attraction force between the particles. This thing you have to remember, right? That's all, right? Do you get my point? Understood? Hmm?
Yeah.
So that's the thing we do, right? Suppose so you got a question over here. This thing you can do, na? See, uh, this thing, this equation do it.
Uh,
This question is what? This question is P1 V1 by T1 equal to P2 V2 by T2. You're changing. Your language says that we're changing the temperature to a new temperature, volume to a new volume. What will be the pressure? Here, there's no such vocabulary of changing the pressure. Here to use PV equal to nRT, right? Directly, right? That's all. That's it. Moles you're getting. Then see, moles is equal to what? Mass by mR. Molecular weight. Mass is given how much? You have to convert to
uh,
what? Grams. Right? So this
grams,
thing
yeah.
you have to understand, right? 2.1 10 to the power minus 3, right? Don't have to do, don't have to leave, go to the next part, right? Understood. We're going to the next part, right? Thank you.